Hello everyone, welcome back. In this video, we'll be discussing about the relative strength of acids and bases, particularly the pH and pKa concept. Now, let us first discuss what is a pH scale. Now, it's a very common scale, a very famous scale developed by Sorensen to express the acidity or basicity of various substances, which is very common in our day-to-day life also. You can see in the video there are various substances which we use in our daily life and their pH is given. Now the question is, how do we calculate the pH? So according to the definition of pH, it is the negative logarithm to the base 10 of the hydrogen ion concentration which is present in the solution. So pH is nothing but equal to minus log of H plus. The other question is, why do we represent the hydrogen ion in terms of pH? Sometimes representing the acidity in terms of hydrogen ion concentration alone is not very convenient or not very intuitive. So, pH is a way or is an index to express the acidity or basicity of a substance or to express the hydrogen ion concentration in a solution. If the pH which we calculate comes out to be less than 7, then the solution is said to be acidic. If the solution for whom the pH has to be calculated comes out to be more than 7, then it is basic, and the solution whose pH is equal to 7 is said to be neutral. Just as the pH, what we have discussed, represent the hydrogen ion concentration, similarly the concept of pOH or pOH represents the hydroxyl ion concentration. The definition goes as same as pH. pOH is equal to minus log of hydroxyl ion concentration. Now, there are few relationship between the hydroxyl ion concentration and hydrogen ion concentration and pH and pOH, which are very important for solving numerical problems. Two such important relationships are shown in the video. The product of the hydrogen ion concentration and hydroxyl ion concentration is always equal to ionic product of water, that is 10 to the power minus 14, and the sum of the pOH and pH always comes out to be 14. So this two expression or the relationship becomes very important for calculating various numerical problems based on pH and pOH. Our next topic is pKa. Now, we know that whenever an acid dissociate, it makes the solution acidic by releasing a proton. And that acidity or the hydrogen ion concentration can be easily expressed in terms of pH, which we can easily calculate by taking the negative log of the hydrogen ion concentration. Now, whenever the acid is a weak acid, remember that weak acid are those acid which do not dissociate to or do not dissociate to a complete extent. Some of the acid will remain in undissociated form. So if the acid remains in undissociated form and some of the acid will go for dissociation, there exists an equilibrium between dissociated and undissociated, which can be seen in the video as the expression or the equation AH reversible sign gives A minus plus H plus. Now A minus and H plus is the dissociated form of the acid and AH is the undissociated form. We can write the equilibrium constant for this particular dissociation equation, and we know that equilibrium constant is nothing but the ratio of the product to that of the reactant. Since it is the dissociation of an acid, that's why it is known as the dissociation constant of an acid, which we represent as Ka, not K. So it is nothing but A minus and H plus by AH. Now try to understand, when Ka value becomes higher, if we get the Ka value which is high, what does that mean? That means the numerator of this particular expression has a higher value and the denominator has a lower value. So if the numerator has a higher value, that means the concentration of the dissociated form in the solution is more. That means the acid is dissociating easily. That means the acid is releasing proton easily in the solution. In another way, we can see it as that the acid is a strong acid. Similarly, if the value of Ka comes out to be less or have a lower value, that means what? That means the denominator has a higher value than the numerator, as a result of which the concentration of Ah becomes more, which means that the dissociation of the acid is very less, so it releases very less H plus. That means the acid is a weak acid. So that is what is written. Ka expresses how easily the acid releases a proton, but expressing the acidity in terms of Ka constant alone can be inconvenient and not very intuitive. That is what we have discussed in case of pH also, very much the same. So in a similar way, how hydrogen ion concentration was expressed as pH by taking negative logarithm, same way the dissociation constant can be expressed in terms of pKa by taking the negative logarithm. The concept is exactly same. Therefore, pKa was introduced as an index to express the acidity of acid and is defined as pKa equals to minus log of Ka. It is the same as pH. For example, Ka constant for acetic acid, you can see the value. Okay, it's very inconvenient and very small. So such value can be written as 10 to the power 4.8. Now, it becomes very difficult to express such value or to remember such value and to express the dissociation constant of acid, particularly the acetic acid. But if we convert that same value to pKa, what we get is 4.8. It becomes very convenient. That is the reason why we prefer to express the dissociation constant in terms of pKa rather than Ka. The smaller the pKa value, the stronger the acid is. Always remember that. Smaller value of pKa means the acid is stronger. Similarly, for bases also we have a concept called pKb concept, which is same as pKa concept. It is nothing but minus log of Kb, where Kb is the dissociation constant of the base. And again, in the very same way, the smaller the value of pKb, the stronger is the base. So always remember these points. Let us try to discuss few problems so that we become clear about the concept of pH. So the question goes as pH of 0.001 molar NaOH will be, so the options are given 3, 2, 11 and 12. So how to solve it? So we know that NaOH dissociate to give you Na plus and OH minus. So below NaOH you can clearly see that I have written 0.001 molar, that is given. Now if 0.001 molar of NaOH is taken, how many molar of OH minus I'll get? 0.001, because according to the dissociation equation, 1 mole of NaOH gives me 1 mole of hydroxyl ion. So 0.001 molar will give me 0.001 molar of hydroxyl ion. So the concentration of hydroxyl ion is 0.001 molar, which is equal to 10 to the power minus 3 molar. Now POH, we know the definition, it is minus log of OH. If I substitute the value of OH as 10 to the power minus 3 and calculate it, what I get is 3. Now the question is not about calculating POH but pH, and I have told you to remember those two important relationship. So POH plus pH will be equal to 14, then pH will be equal to 14 minus 3, which will be 11. So that is how we calculate it. Let us move into the next. Hydrogen ion concentration in mole per liter in a solution of pH 5.4 will be. So it is just the opposite question. in the previous question, what was given was the hydroxyl ion concentration, and then we calculate the pH. Over here they have given the pH and tell us to calculate the hydrogen ion concentration. So the various options are given. So pH is equal to minus log of H plus. So similarly you put the value of pH 5.4. Then to calculate H plus we must take anti-log of minus 5.4. If you do that, what you'll get is 3.98 into 10 to the power minus 6. It's a very simple and straightforward question. Let us move into the next. Given the dissociation constant for water is Kw, which is equal to 10 to the power minus 14, as I have discussed in the previous section, what is the pH of a 0.001 molar KOH solution? And the options are given. So 0.001 molar KOH solution means it will give me the same molar of OH minus in the solution. That is what we have discussed in the first problem. Same way, because 1 mole of KOH will give me 1 mole of OH minus. So 0.001 molar will give me 0.001 molar of hydroxyl ion concentration, which is equal to 10 to the power minus 3. Now, as I have told you to remember that relationship between hydroxyl ion concentration and hydrogen ion concentration, which is equal to 10 to the power minus 14, which is the ionic product of water, which is given in the question. So hydrogen ion concentration will be 10 to the power minus 14 by hydroxyl ion concentration. When we substitute the value of hydroxyl ion concentration as 10 to the power minus 3, by calculating it, what we get is 10 to the power minus 11. So the hydroxyl ion concentration is 10 to the power minus 11. So if I substitute in the definition of pH and the hydrogen ion concentration, what I get is the value as 11. So that is our answer. So that is how we solve various problems in pH and understand the concept of pH and pKa. So thank you everyone. Do watch various videos for explanation on various topics on chemistry. So thank you very much.